Hello everybody, welcome back to ArxangelRC. I know this has been way overdue, but at last I got around to making that lithium-ion pack for the Nano Talon and installing the iNav autopilot. Somebody asked me if I could do a detailed build and programming video of installing iNav on a plane, and this is it. I hope you will find it useful. If I have missed something, please let me know in the comments below, and I will try to be more detailed next time I install one of these on another plane. All items used for this build have been linked in the description below, and if some are not, follow the link to my blog post for the Nano Talon and you should be able to find them in the parts list there. Let's start with the battery. I decided to go with the Sony LiIon 3120 mAh cells, which have a 30 amp discharge rating. Since the battery will be 4S1P, I thought these cells would better handle the 13 amp max draw of the motor during takeoffs and climbs and would suffer less voltage sag and the load overall. First, I arranged the cells in the proper order for a 4S1P pack and used tape to hold them roughly together. I decided to use my spot welder to assemble this pack just so I can see how it will handle being done that way. Since probably most of you do not have a spot welder, you can also solder these into a pack. Just make sure you use a very strong soldering iron and apply heat to the cells for very short periods of time so they won't overheat and get damaged. With the nickel strips cut into the proper length, spot welding this is very quick and easy, and in no time I had the pack assembled and almost ready. Next, I had to add the balance wire. For the purpose, I cut lengths of silicon wire and soldered them between each of the cells and add the plus and minus for the whole pack, so 5 in total. For soldering directly to the cells, I set the soldering iron to its max heat setting of 480 degrees, just so I can keep the soldering time to a minimum. Once the balance cables were done, I soldered the power cables to an XT30 connector and then soldered that to the battery, again making sure to keep heat on the cells for as short a time as possible. And last, I soldered the balance cables to a balance connector, making sure to observe the proper order, starting from the minus and finishing with the plus cables. Connecting the finished pack to a charger revealed that I had done everything correctly and now had a functioning pack for using the Nano Talon. Next, it was time to work on the flight controller and its peripherals, starting with the receiver. Ideally, I want to mount an L9R receiver on this one, as I've had very good results with it on my XUAV clouds, but initially I really want to test the range on an XM Plus receiver, so I'm going with it for the time being. Since I will be connecting it on UART1, I will need to add a cable with the proper connector, and luckily I have a few of those. I removed all of the old wiring and directly soldered the connector with a length of wire, which I think should be enough. Next, I had to make a power harness for the servos, because I never power them via the flight controller. This is a very simple thing to make. I just take a triple pin header and cut off a 5 or 6 row piece out of it. Then I solder the middle and one of the outer rows together. This will distribute the ground and positive from the back to all servos. To the remaining row, I then solder the signal wires coming from the flight controller, which I had soldered there beforehand. Last, since I can't find my hot glue gun anywhere, I epoxied the back of the pin header just to make sure it will not touch anything by accident and cause a short. Better safe than sorry, right? Now, since I had put this stack together quite a while back, I had done some of the soldering back then, but it is pretty straightforward. Since I'm using the Omnibus F3 Pro board, it has a current sensor on it, so input wires from the battery go there. From there, I solder them to the Matek PDB, which actually has some very well fitted 5V and 12V outputs with enough amps to comfortably power a few cameras and video transmitters at once. On that PDB, I also soldered some pins so I can easily connect the camera and video transmitter without any additional soldering. What was missing though was a set of pins for the video in and video out cables, as well as an output for the servo's back. Since I didn't want to dismantle the stack, I just opened it up a bit so I can solder in a GST connector with cables for the back, and then I also soldered a dual pin set for the video signal cables to and from the Omnibus board. Having a current sensor and an OSD on the board really makes wiring these things so much easier when you don't have to deal with separate modules, and it also saves a ton of weight. To finish this off, I would also need a GPS unit, and I had soldered an extension cable with the proper connector to my GPS of choice back when I also did part of the wiring on the flight controller, so it is ready to go. And with that, I was ready to connect everything up and see if it works. Since the version of iNav I am using on this board is 1.73, I will not be updating it to the most recent version at this time, but that means I will need to make a V-tail mix for the Nano Talon, as that tail configuration is not supported by default in iNav 1.73. Painless 360's V-tail mix is absolutely perfect and has worked very well on my Believer. On first try, it turned out that I had connected the servos wrong. A quick rewiring fixed that, but then it turned out that the ailerons channel is reversed. A word of warning here, do not fix that from the radio. You actually need to reverse it from iNav so that it could work the right way in the stabilized modes as well. If you only reverse it from the radio, it will work okay in the pass-through mode, but will try to roll over in any of the stabilized modes, as it will stabilize in the wrong direction. You can reverse a servo channel by going into the configuration, click on the servos tab, find the servo channel which needs reversing, and from the drop down menu go from 100 to -100, then don't forget to save. Also keep in mind that inside the firmware, channels are counted from 0 up, not from 1 up as is in the wiring diagram. So in my case, the aileron servo was connected to output 4 on the wiring diagram, but that equals output 3 inside the firmware. It is important so you don't reverse the wrong channel. I also took the chance to give a 180-degree correction angle on the board's yaw alignment axis, since the board is mounted with the front facing backwards for more convenient wiring purposes. Also, don't forget to turn that throttle to elevator mix down to 0, because this out of the box is set up for flying wings, and on a normal plane you don't need that mix. It will absolutely try to kill any normal plane. So if you're not mounting iNav on a flying wing, please make sure you set that to 0 and click save. So now that we've made sure that all control surfaces are working and stabilizing in the correct directions, it was time to finalize the build by connecting the motor to the ESC. For a while I was thinking of soldering the motor wires directly, but that meant having to desolder every time I had to change anything, so instead I decided to solder some 2mm connectors onto the Cicada 30A ESC, which I had soldered to the PDB and flight controller earlier. This wasn't too difficult of a task once I got the hang of it, and then makes changing motor direction very easy by just swapping 2 of the cables around without having to desolder anything. And finally it was time to wire in the FPV system. For some reason my split was acting up and just refused to boot up properly, so I resorted to using the Foxeer that was already in the plane until I can sort out the split. The wiring for this was very easy, since I already had pins for power from the PDB and for the video in and out from the flight controller. On the video transmitter I removed part of the original wiring and crimped on a GST connector along with a single pin servo connector for the video, and for the camera I used a double pin servo connector for the power and a single pin one for the video. Once the wiring was done and camera and video transmitter installed in their respective places, I mounted the GPS unit on top of the wing carbon rod holder, as it seemed like the most proper place for it. I had to melt away an equally large hole in the hatch so it will fit over the GPS, and I think it turned out pretty good. This plane was finally ready to take its first iNav powered flight. I was truly happy how it turned out in terms of wiring and how tidy it looks, despite the huge capabilities that it has. Some of the wiring could have been done better in order to optimize its length, but I may leave that for another day if I don't lose this plane until then. You know, long range is a risky business, especially with a model held together by magnets and quick wing snaps. So before first flight I had to set up the CG, and as it turned out the battery did have to move back a bit. It was still just a tad nose heavy, but I decided to leave it like that for the time being, as it is always better to be slightly nose heavy for a maiden flight, and with the new electronics in there, this was sort of a second maiden for this plane. I love the fact that from the outside you can't really tell that the plane is equipped with an autopilot, and its size and weight certainly do not suggest long-range capabilities or close to 2 hours of theoretical flight times. Yes, since the lithium ion in there now has pretty much twice the capacity of the lithium polymer I used to fly for 1 hour, I can assume with relative certainty that it may get close to 2 hours in the air, and I will test that very soon. And now a friend-assisted takeoff sent the plane flying into the air, and since I reset all my trims when I put the iNav in there, I had to trim it again, and it did take quite a lot of trim on the elevator to make it fly level. So I assume I can safely move the battery further back next time around, which will also make the plane a bit floatier and would improve cruise efficiency. As fate would have it, the day of the flight was absolutely perfect in every possible way. The sun was out and it was relatively warm, and there was absolutely no wind to speak of. As you can probably see, in the pass-through mode the plane was absolutely perfect and smooth in the air. Good news is the voltage reading was almost spot on, might have been showing slightly lower than it was, but that is easy to calibrate. But the current sensor once again showed that it is way off. Thankfully I have the one on my believer pretty well dialed in, and since the flight controller is the same, I will use the same scaling here, and hopefully that'll fix it. The OSD was perfect, RSSI worked very well, only the home arrow was acting up for some reason. We'll have to look into it, as it wasn't really pointing towards home. So then I flipped the mode switch into the gyro mode, and the plane started to veer off course and try to roll and pitch up. And at that moment it hit me that iNav takes 1500 signal as middle or neutral point, but since I have trim on all channels, it interprets that as stick input, and hence the plane starts flying to the side. There is an easy fix for this, but I didn't have time to do that after this flight and then fly again, so we'll show you how to fix it in the next video. Basically you have to take the new middle values from your radio and tell iNav that these are the middle points on these channels. For that same reason the angle mode also did not work properly, although it did seem to be doing a good job of stabilizing the plane while I was keeping the sticks offset a bit in an attempt to counter the trim I had dialed in. But setting this up is a process that will take time and tests. Moving to the battery, I couldn't help but notice that even though most of the time I was flying at higher throttle than what was needed for cruise, the battery voltage stayed relatively high throughout the whole flight, only rarely dipping below 15 volts, which is quite intriguing for a lithium-ion battery considering it can go down to 12 volts before I would land it. It might even go a bit lower than that, since some lithium-ions can go down to as low as 2.5–2.6 volts per cell, and don't forget this is a 4S battery. Even with the current sensor showing the wrong values, I was still able to determine that the Nano Talon cruises at around 1.5 amps and around 50 kilometers an hour pretty comfortably, so the potential for long range and endurance is certainly there. For the next video I will do my best to get the split working so I can also have some HD onboard footage, and I will get the trims and other programming sorted so I can test all of iNav's functions before I do a proper endurance, and hopefully after that a proper long range. Theoretically I should have enough juice to take it out to at least 40 kilometers and back, and even though neither the video system nor the radio system can go that far yet, it is nice to know it can do it. So stay tuned for the next video on the Nano Talon with more updates on iNav and the performance of the lithium-ion battery pack. Meanwhile, if you have liked this video, please don't hesitate to like, share and subscribe if you haven't already, and consider doing the same on Facebook for daily updates. All relevant links can be found in the description below, so should you decide to buy literally anything through them, your support for this channel would be greatly appreciated. Happy flying, and until next time.